So what we can do over here is that we can write hexane, structure of hexane. Okay. CH3, CH2. So this is hexane, 6 carbon atom. Normal hexane means it is a straight chain, there is no branching. Okay. And Imad, which alkyl halide you need to take here in order to get a hexane?
CH3.
Which one?
CH3.
Yeah, you can, what you can do is you can just cut it into half.
Okay.
So if you cut it into half, you will get 3 carbon atom alkyl group. Okay. So you, what you can do is you can take propyl chloride and propyl or 1 propyl chloride or 1. The propyl chloride is normal common name. You react it with sodium in the presence of ether. Okay, that's what we have seen in the last class. Okay, so propyl chloride, I will write the structure. This is 1 chloropropane is IUPAC name. Anushka, is it clear?
Yes, sir.
And if you want to write the complete balance equation, you need 2 moles of sodium and 2 moles of propyl chloride. Clear? Just
Yes, sir.
yeah, just do it like this. Remove the chlorine, remove Na. Okay, and you need to take ether. The ether should not have any water. Why? Suppose if the ether is having water, then what will happen? The sodium can react with water, so sodium will get spoiled. Is it clear? So what you can do is you can take dry ether. Dry ether means it doesn't have water. Remove NaCl and you will get So what is the name of the reaction if you take an aromatic halide in place of alkyl halide? Remember, Anushka, Nimad, can you tell me the name? Yeah. So suppose if you want to, if you take a benzene, chlorobenzene. So this is Wood's reaction.
Okay.
Right?
Yes, sir.
Wood's reaction, you take haloalkanes, okay? And from wherever the Cl or I is attached, so from there, that is a point from where you attach the 2 alkyl groups. The next is, suppose if you take benzene, chlorobenzene. What is the name of this reaction, Anushka? Is it a Woods reaction? It is Woods, but the name is different. If you take an aromatic halide, the name is going to be Imad. Can you recall the name?
Sir, Wood's Pvt.
Yeah, it will be Pvt. Yeah, very good. Phytic reaction. Okay. And if you take only aromatic halide, Woods phytic will be, Anushka, when you take one aromatic and one normal haloalkane. So if you take two different type of alkyl halide, then it is Woods phytic. So with phytic, you get a biphenyl. Right? And with Woods phytic, you can take one benzene, chlorobenzene, you can take sodium. Okay, suppose if the question is not given with 2 sodium, still you can do it. Okay, don't think that somebody will give you the equation which will be completely balanced. If someone writes sodium ether, you should do it. Okay, this is just I'm writing it in a complete balanced manner. So this is going to be Woods phytic because this is an aromatic halide and this is alkyl halide. Okay, so this is one reaction of alkyl halides and that we have seen, right? And just let me show it to you. Okay, it's there in the in the NCERT book also, right? And you can see these are the physical properties. This is all what we have done, nucleophilic substitution reactions. Okay, and this is the mechanism of SN1 and SN2. In SN2, there is an inversion which happens. That's what we have seen. Okay, and bimolecular nucleophilic substitution that we did. Okay, and this is it is given in the last. Yeah, this one. Okay. This is phytic, and this is Woods phytic, right? And simply, if you take an alkyl halide, that will be Woods reaction. Is it clear? Okay. Yeah. So let's move with another reaction. So this is reaction of alkyl halide with metals. So this is the sodium is a metal. And there is one more reaction which is very famous and that will be useful not only in this chapter but in all the upcoming chapters. Okay, that is the reaction with magnesium. Right? So with magnesium, what is there? How the reaction happens? That let's see that. Okay. So suppose if you take an alkyl halide Rx reaction with magnesium, right? Okay, reaction with magnesium. If you take Rx or any alkyl halide, alkyl group, generally we denote it by R, and halogen by X, it can be Cl, Br or I, right? F is generally less reactive, so we take it in less amount. And what will happen if you react it with magnesium? Magnesium is solid metal. Okay, you have small pieces of magnesium, broken pieces of magnesium. Okay, you put it in the ether. Ether is solvent, very famous solvent. For this reaction, you heat it slowly and you put your alkyl halide. Yeah, Anushka, any idea what is going to happen? Himad? Yeah. So what happens here is, so I will write a overall reaction. the magnesium will be inserted between the alkyl group and the halogen. Yeah. How it is possible that the magnesium got inserted? Yeah, Anushka, any idea?
No, sir.
Tell me. How come is it possible that the magnesium group is inserted? So let me show you. What you can do is, magnesium is a metal, okay, and metals have tendency to lose electron. The atomic number of magnesium is 12. So 10 plus 2. So 2 electrons magnesium will give because it has 2 outermost electrons. Is it clear?
Yes.
2 electrons. Sodium is actually from group 1. Alkali metal have only 1 electron extra. So they lose only 1. Okay. And your magnesium, calcium, they have 2 electron extra than the noble gas. So they give 2 electrons. Okay. And they form a di-positive ion. And this RCl, suppose if you want to break this alkyl halide, right? Suppose it is CH3Cl or ethyl chloride. It can be any R. Okay. So how will you break this R and Cl bond? Suppose CH3Cl is there, or Cl is actually more non-metallic. It is more electronegative. So you are going to break it as CH3 minus, Cl minus and CH3 plus. Clear? Okay. So
Sir,
yeah,
sir, could you just explain this again?
explain what?
So like how the Mg came in between the alkyl.
How the
and
Mg is a metal and it has the atomic number is 12, 2, 8 and 2 electrons are there. Okay. So these metals have a tendency to lose electron. Okay. How many electron will it lose? 2. Why 2? In order to have noble gas configuration. Now the remaining magnesium 2 plus is having how many electrons? 10 electrons. Okay.
Yes, yes, sir.
So where these 2 electrons will go? So CH3Cl or alkyl halide which you have taken, that will react with these 2 electrons. Okay, carbon has plus charge, Cl has minus charge. So carbon plus will gain 2 electron, it will become carbon minus. Okay, so actually this magnesium, when it reacts with CH3Cl, let's say, okay, this is RCl. I can write this. So it changes to CH3 MgCl. Okay, this whole magnesium, those 2 electrons are taken by CH3Cl, the magnesium. So CH3 plus, Cl minus, CH3 plus will get 2 electrons, that will also become CH3 minus Mg. So CH3 minus is there, Cl minus is there, and Mg2 plus is there.
Yes, sir.
Okay, that's how you get. So this is known as Grignard reagent. This belongs to a class of compound known as organometallic compound. Okay, is it clear? What are organometallic compound, Iman?
Which compound?
Organometallic. Yeah.
I have no idea.
Yeah, it is in the compound in which the carbon is directly linked to metal. Okay, so when you react alkyl chloride or bromide with sodium, the chloride or bromide will get removed and the two alkyl groups will join together. Okay, clear? But if you react it with magnesium, it will form a Grignard reagent. Yeah, Iman.
Sir, explain what was Grignard reagent again?
Yeah, Grignard reagent is actually you take alkyl halide, chloride or bromide, and you heat it with magnesium in the presence of ether. So the carbon chlorine or carbon bromine or carbon iodine bond is broken, and magnesium comes in between the carbon and the halogen. Look here, the magnesium it comes in between. Is it clear, Anushka?
Yes, sir. Now
Yes, sir, understood.
Yeah, this is known as Grignard reagent. Okay. So what is the difference? Why we need to take Grignard reagent? This comes under reaction with metals, and Grignard reagent is the carbon which is there in the Grignard reagent, the alkyl group, the carbon of the alkyl group which is directly connected to magnesium will have negative charge. Okay, why will it have negative charge? Can you tell me? How will you explain? Metals are what? Metals are electropositive. Okay, means they have a tendency to give electron. So metals actually form cations. Okay, Mg plus. So if metal is a cation, okay. So what is the charge on the carbon which is directly connected to it? Tell me. What is the charge? Minus charge, because overall this is a neutral compound. Okay. Is it clear?
sir, but is there nuclear plus reaction in this?
Yeah, it is neutral. Actually, you need to think in this way that actually this CS3 is there, magnesium is there, Cl is there, but these bonds are not perfectly covalent. Okay, because metals are electropositive, so they will have plus charge. Okay, partial positive charge you can think, and the carbon group is relatively more electronegative, so it is having a minus charge. Is it clear?
Yes, sir.
Yes, sir.
So these Grignard reagent, yeah, there is a question in your NCRT why Grignard reagent should be prepared in anhydrous condition. What is the reason? Why you need anhydrous condition for Woods reaction? What was the reason?
Sir, because if there is even a single drop of water present, then the reaction won't occur.
Yeah, actually your whole sodium will get spoiled. Sodium will immediately react with water, it will give hydrogen and it will become NaOH. Yeah, so your main reaction which you wanted to carry out will not happen. Okay, and the main reaction which you wanted to carry out was Woods reaction, that will not happen. So with not only with the, so this was a problem which we have seen in Woods reaction, that your ether should not have any water, should not have any alcohol also. Okay, so same is the case here also. While preparing Grignard, the ether should be dry. Okay, what will happen during the preparation of Grignard reagent? This is a general way of writing R, Mg, and X. R can be methyl ethyl propyl, X can be ClBrI. So ether should be free from any alcohol or water impurities. It is because R is there, magnesium, so and halogen. Halogen is having minus charge. R is having minus charge. Magnesium is having +2 charge. You can think in this way. Okay. So this R minus. Suppose if you have water, if you have any of these, water or alcohol, they all give H plus. Okay, because hydrogen is actually connected to oxygen. So oxygen will pull the electron and H plus will come out. And R in Grignard reagent is having minus charge. And suppose if you put something which is bringing in the H plus, what will happen? This H plus will combine with R minus and you will have alkane, RH. And what you will get with the H plus OH minus MgX. So your whole Grignard reagent will get reacted with the water. Okay. Suppose if you have taken any water or alcohol, they will give H plus. H plus actually will react with the alkyl group and you will end up with an alkane. Is it clear? So look here. So yeah, let's do this question. Okay, just try it quickly from your in-text problems. Okay. Just a second. Just you can try it quickly. 10.9. Yeah, tried it. So this is bromocyclohexane. Can you see this? Yeah,
Yes, sir.
Anushka,
Yes, sir, I can see.
Ryan, can you hear my voice? Imad,
Yes, sir.
yeah. So what will happen? Mg will give 2 electron, will become magnesium 2 plus, and magnesium you need to insert on the carbon halogen bond. That's it. Okay. So what you will get? Okay. Is it clear? Ryan,
Sir, how did you get MGVR?
actually, This is the thing which we were discussing, that the magnesium will give 2 electrons. Okay. And what happens is R breaks into R plus and Cl minus. R is general way of writing. So magnesium gives 2 electrons. Those 2 electrons are taken by R. So R become minus. Cl is also minus and Mg is 2 plus.
Okay.
Okay.
Yes.
So that's how you have CH3 MgR RMgCl. Okay. So but you don't have to write the step-by-step procedure. Right? Ryan, Anushka, Himad.
Yes, sir.
Just what you can do is, in sodium, what you can do, you can remove the 2 halogen and you can join the 2 alkyl group. Okay.
Okay.
But if magnesium is given, cut the alkyl halide and put the magnesium in between the carbon and the halogen atom. And this is known as Grignard reagent, right?
Yes.
And specifically, we have mentioned just now that while preparing Grignard, water should not be there. Otherwise, what will happen? The Grignard, the minus in the Grignard, the whatever the carbon atom is there, that will have negative charge. Okay. And if water is there, that negative charge will take H plus from the water and will convert to alkane. Okay. So here we took dry. The dry means there should be no water. But what will happen? Suppose if we take Grignard and if in this case we are actually deliberately reacting it with water. Okay, you can see that we are reacting this Grignard with water. So what is going to be the B? Option B. Rayan, can you hear my voice? So what will
Yes,
happen?
sir.
Yeah, so what will happen? Water actually you can think as H plus and OH minus. Okay. And in Grignard, the magnesium is +2, so the carbon is minus. So the carbon group which is there, whatever the carbon group which you have taken, and in this you have taken the cyclohexyl group, Anushka, so that carbon is having a minus charge. And if you react it with water means H plus, what you are going to get? What will be the B? What is the structure of B, Imad? Yeah, so it was it was MgBr. You are going to remove this minus, you are going to put H plus from the water. Okay. So where this OH will go? Where this OH will go? This OH will go with, so but we are not bothered about this OH. Is it clear?
Yes, sir.
Yes, sir.
Right. So you will get an alkane. No need to write the H. I have shown that just to bring to draw your attention. You can write simply cyclohexane. So Grignard reagent, if you react it with water, you will get an alkane. Clear?
Yes.
Yes,
Okay.
sir.
So this is cyclohexane is the answer. And okay, this is another question. Rayan. So
Sir,
RBR,
here the C will be RMGBR, right?
pardon?
In the next question, the C will be RMGBR, right?
Yeah, RMGBR. But we still don't know what is R. It is yet to be deciphered. So let's do C is correct. It is RMGBR. Yeah, and if you react it with D2O, what is D2O?
Sir, H2.
Yeah, it is H2O, but H2O having heavy hydrogen. Okay, that the deuterium having one proton and one neutron. Okay, deuterium actually is a heavy hydrogen, so it is D. So actually, it is just like reaction with water. So water gives H plus, and that H plus can get connected to the carbon which is connected to Mg. Okay, but suppose if you are having RMGBR, Okay, what will happen? The R minus will get connected to that D plus, which is released from the which is released from the D2. Okay, so here is what you get. They are not asked you what you will get. Okay, this is similar to, in terms of R, it will be RD. Okay, clear? So R is this group. Initially, they have not shown you what is R, but they have given you the final answer. This is RD. Okay, the D, suppose this was RH. So this is RD. Okay, is it clear?
Yes, sir.
So R was which group? What is the IUPAC name of RBR? Was it 1 bromopropane or was it 2 bromopropane? The RBR which you took initially, which you reacted with magnesium, was it this one, 1 bromopropane, Ryan, or was it 2 bromopropane?
Sir, it was 2 bromopropane.
Yeah, which one?
Sir, 2 bromopropane.
Yeah, 2 bromopropane, not 1 bromopropane. How you identified it? By, yeah, by looking at the position where the D got connected. Okay, because initially at the second position the BR was there, so at the second position that BR got converted to MgBr. Okay, and that MgBr actually was displaced and the D plus got joined to that point. Okay, so this is already shown to you, so you need to think in backward direction to know what was RBR. So just to bromopropane. Imad, Ryan, is it clear to both of you?
Yes, sir, clear.
Yeah, okay. So now the next question is actually reaction with sodium, which is Wood's reaction. Okay, and on one side, on left hand side it is Wood's, on right hand side it is Grignard. So Wood's reaction also you can work in the backward direction to understand what alkyl halide you took. Okay, so whatever the alkane which is given to you, just cut it into half, equal to equal half. Okay, why I'm cutting it into two equal half? The reason is because after doing Wood's reaction, the size of the alkyl group get doubled, and Wood's reaction is suitable for the preparation of alkanes containing even number of carbon atoms, because in the Wood's reaction the size get doubled when the two alkyl groups join together. So if the final alkane is given and the original alkyl halide is not given, then our question is which alkyl halide is taken here? That is not given, but indirectly they are telling you by giving you the final answer. So by looking at the final answer, you need to cut it into two half. Okay, because in Woods that get doubled, and where you cut it, put halogen. Okay, so this R1X is CS3, C, CS3, CS3, BR. Is it clear? And when you react it with sodium, it will get doubled, the BR will get removed and two groups will join together. Clear?
Yes, sir.
Okay.
Understood.
Yeah, understood. So we need to work back. Sometimes answer is even we need, so the question is asking what is the structure of the original reactant. Okay, now this is known, we can start working in the right hand direction. Ryan. So with Mg, what will happen? With magnesium, yeah, with magnesium, the magnesium will get it. Is you don't have to write each and every detail. Just write wherever you see halogen. Just write Mg and halogen together on the along with the alkyl group. No need to write the complete thing. That is not required. Okay, mechanisms and all. So C MgVm. Okay, I've written it in condensed manner by putting these three alkyl groups as CH3 ultras. So this will be the structure of the D. Okay, and if you put water, what is going to happen? So wherever the MgBr is there, the carbon alkyl group has minus charge. Okay, and with water H plus will be released, and H plus you are going to put at the carbon atom. So what is the IUPAC name of the compound E? Can you tell me quickly, Mark, Rayan, Anushka? E. What is E? Yeah, quickly tell me.
Sir, it will be CH3 whole 3 CH, right?
Yeah, CH3 whole thrice CH, correct. CH3, 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 and wherever the magnesium was there, that there I put H. The H is given by the water. Okay, so this is the alkane having 4 carbon atom. The common name is isobutane. Okay, in iso you have one alkyl group in the middle. Okay, on the second last, isobutane. But the IUPAC name is iso neo, and they will not work in the IUPAC name. You need to select the longest chain. That is of 3 carbon atom. Do the numbering 1, 2, 3. And on the second you have methyl group. So 2-methyl propane is the IUPAC name of this. Is it clear? 2-methyl propane. Right? That is IUPAC name. And iso butane is the common name. Okay. So I hope this is clear. Right? So
Yes, sir.
yeah, okay, good, very good. So let me ask you just a quick recap, and then we will move on to the next question. So Grignard, you don't forget, you should not forget, because it is going to be useful in the next chapter, next to next. Okay, on all the chapters in organic chemistry, Grignard will be there. Okay, and how Grignards are prepared? It's very simple, by treating alkyl halide with magnesium in the presence of ether. That is very simple. Okay.
Sir,
So yeah.
so Grignard reagent can be only take place with Mg, right? Not with any other.
Yeah. With only with Mg, because for other metals there are other names and they are not Grignard. They are called something else.
Yes.
Okay. So just quickly, we can do one question to revise SN1 and SN2 also. So which one will react faster with SN2? What is the rate of SN2 reaction? Which one will react faster? More rapidly by SN2 reaction? Just quickly. Yeah, Ryan. Which one is SN2? Remember how SN2 used to happen? Quickly tell me. Suppose this is your alkyl halide, okay, and this is yellow one is a leaving group. What happened? The nucleophile used to come and attack on the carbon, and the leaving group used to come out. Okay, clear? So the new group will be joined from the back side. Okay, and these 3 groups, they will turn that side. Okay, yellow group will come out. That's what we discussed. So 2 molecules were getting involved simultaneously, and that was SN2 reaction. substitution nucleophilic bimolecular. Okay, and it was very crowded. When the reaction was happening, it was actually very crowded structure because the leaving group was coming out and the nucleophile was joining in, and all were happening simultaneously. Okay.
Sir, but for the third this question, sir, but these are 2-degree alkyl halides.
Pardon?
Are these second degree alkyl halides?
Yeah, second degree alkaloid. Yeah, they used to react slower.
Okay.
Yeah, second degree alkyl halide used to react bit slower. Primary alkyl halide are the alkyl halide which are having maximum number of hydrogens on that carbon which was carrying the halogen. So they used to react fastest.
Okay.
But here both are primary. Now, how will I decide the rate of SN2? Rayan, Anushka, Imad, quickly tell me which one is going to react, which one is going to get attacked by the nucleophile more quickly. Yeah, A or B, which will react more rapidly and why?
Sir, A, I think.
Yeah, A. Why A?
So because it suffers greater steric distance.
Yeah, actually wherever the nucleophile is attacking in SN2, on primary SN2 will happen. You need to look at the branching or groups. There should be less number of groups. Okay, and the group should be away farther from the site where the nucleophile is attacking. Okay, so look here. So this crowding, this branching is away from the site where the reaction is happening, right? And this branching is close to just adjacent to the carbon atom where the nucleophile is attacking. So this crowding and all will slow down. It will slow down the attack of nucleophile. Is it clear? Our nucleophile will get repelled and it will not be able to attack. Is it clear or not?
Yes, sir, understood.
So if you have more and more steric hindrance, lesser and lesser SN2 will happen. Okay. For example, this will happen, react more rapidly and this will react slowly. Okay. In this one, this will react more rapidly and this will react slowly because this is tertiary, more alkyl. Okay. For SN1, it is just the reverse case. You need to look at how there the nucleophile is not coming in directly. First of all, that can't come in. Okay, nucleophile can't come in because it's very crowded. So what happens? The leaving group, the Cl, by heating it breaks away slowly on its own, and then the group which want to join is joined. So, but there you can't look for the steric hindrance. Okay, there actually this branching is useful in SN1. What we discussed was in SN1, more and more branched the carbon atom is, more the cation is going to be stable. It is going to form more easily because these carbon alkyl groups are electron donating, so they will make the cation very stable. So in this case, it is just the reverse. SN1 reaction is more for secondary and primary. For tertiary, it is maximum, then secondary. Is it clear? Any doubts in this?
No, sir, no doubt.
Yeah, just a quick recap, Rayan. I hope you can hear me. Now let's move to the new reaction of alkyl halides, and those reactions come under the category of elimination reaction. What are elimination reactions? What do you understand by elimination?
So removal of the alkyl halide.
Pardon?
So elimination reaction of alkyl halide means removal of the alkyl halide.
Yeah, correct. So two groups are removed, not one. Two groups are removed permanently and no other group take their place. Okay. And this reaction we will see in the next chapter also, alcohol. So suppose if you remove these two groups, what will happen to the two bonds through which these two groups are connected? Yeah. Tell me, what will happen to the two bonds through which two groups were connected? Will they remain as it is? You need to satisfy the bond, you need to make the complete bonds. Yeah, Ryan? Anushka?
So it will make a separate bond, right? A different
Yeah,
bond.
what will happen? Suppose if you have removed H and Cl, Imad, the two bonds will join among themselves only.
Okay.
So CH2 double bond CH2. Okay. So this is, so they will join because already there is one bond. Okay. This bond is already one bond. Okay. And a new bond will come up because these two carbon atoms are now free. So what they will do, they will not remain free. You need to complete the bond. They will join among themselves. And this is an alkene. Okay. So elimination reaction, let me summarize what I told you. Rayan, Imad, quickly. Elimination is removal of two groups. Okay. And there no other group come and take their place. So those two positions from where the two groups are connected, adjacent position 1 and 2, those carbon atom after the removal of the groups join, form one more bond between them. Okay, that is double bond. Okay, and this lead to the formation of an alkene. Is it clear?
Yes, sir.
So you have elimination reaction. You can, so what two groups are removed, and accordingly you can give a general name to the elimination. General name, not the specific one. For example, this is dehydrohalogenation. Means removal of H and halogen. Is it clear?
Yes.
So that is dehydrohalogenation. Okay. Suppose in the next chapter, but the concept is same. Suppose if you take an alcohol and if you remove H and OH, so it is removal of, effectively it is removal of H and OH, means it is removal of water. You will get an alkene again. So what is removal of water known as? Okay, that is known as dehydration. This will be in the next chapter, which we are going to start very quickly. And suppose if you have two halogen atoms removed, initially in the first case we were removing hydrogen and halogen. In this we are removing two halogens. So it is, you are again going to get an alkene, and this is dehalogenation. So alkyl halides undergo elimination reaction by removing the halogen atom and the H plus from the atom adjacent to them. Okay, and the removal of hydrogen and halogen is known by the name of dehydrohalogenation reaction. Okay, and the final product which we get is an alkene. Is it clear? Okay.
Yes, sir.
So out of these most common, this is the most common. Dehydrohalogenation is the most common. So now the question comes, what is the reagent which you are going to take for the dehydrohalogenation? Anushka, Imad, Riyan, can you tell me quickly?
No idea.
Yeah. We can quickly get the idea just by looking at a very small thing. And suppose if you would have taken okay, you are removing H and Cl. Okay, so effectively you are removing HCl. Okay, HCl is an acid. So if you want to remove HCl, you need a base. Is it clear? So how you are going to do the dehydrohalogenation? By heating alkyl halides
Yes,
with
sir.
alcoholic bases. Okay, by heating alkyl halides with alcoholic means they are dissolved in alcohol. So you take a base, very strong base, KOH, potassium hydroxide, and you mix it with alcohol as a solvent, dissolve it because it is solid. Okay, and heat is represented by this symbol of delta. If you heat, you can write in the bracket what is happening. So this base will react with HCl, it will take away the HCl, so minus H plus minus Cl minus. Okay, you're going to get CH2 double bond CH2. What will happen to this HCl? Actually, HCl will be reacted KOH, and that will, these are the byproducts, KCl, and H plus will be taken away by the OH minus. OH minus is so H2. This is dehydrohalogenation. Remember one thing, suppose if you take aqueous KOH, aqueous means KOH is a solid, so if it is dissolved in water, it depends how you prepare it. Okay, suppose if you put that solid and dissolve a solution, make a solution in water, that is aqueous, and if you prepare a solution in alcohol, that is alcoholic. Aqueous KOH if you take, so that is going to be a mild. So aqueous KOH is not going to do the elimination, substitution will happen. This is a very important thing. With alcoholic KOH and in the presence of heat, can you see the delta sign? I'm highlighting. So substitution means what? SN2. This is SN2 reaction. OH minus will come in place of Cl. So this is CH3, CH2, OH. Is it clear?
Yes, sir.
Yes, sir.
Right? So what we have seen, we can go through it quickly. So this is dehydrohalogenation, which is removal of HNCl, means removal of two groups, which is elimination reaction. That for removing HCl, you require a base and heat, alcoholic base and heat. You need vigorous condition. Okay, and you will end up with an alkene. Okay, and but if you take a mild base by dissolving it in water, if you dissolve it in water, that it will not be a very strong base. Okay, and so there only the Cl will be replaced by OH. Okay, so that is elimination. But these elimination are very important for the preparation of an alkene. So let me ask you few more questions, and this is from your NCERT only. So suppose if the two possible products are there, so if one product is forming in prominent amount, that is known as major product. Okay, and C is the minor product, means which is forming in less amount. Minor alkene means it is formed in less quantity because it is not very stable. That is the reason. But we need to, first of all, we need to generate A. Then only we can think of these alkenes and all. Yeah. Yeah, what is A? A, is it elimination or is it the reverse of elimination? And what that reverse of elimination known as? Yeah, Anushka.
Sir, it will be substitution.
It will be
Substitution reaction.
actually how alkenes are formed by elimination. So by elimination, eliminating H and halogen, you get alkene. Okay. And if you do the substitution, actually you need some group which can come out. Okay. And another group can come in place of that. That is substitution. Okay.
Sir, then it will be addition then, yeah, right?
Yeah, it will be addition. Very good.
Add
This is,
it.
yeah, this is reverse of elimination reaction. Imad, is it clear? In elimination, we removed HCl or HBr or HI. In this, you are adding it back. Okay.
Yes, sir.
So this is addition reaction. So Ryan, what was the rule which governed the way of addition of HCl or HBr? Yeah, tell me. What rule actually help us to decide how where we are going to put H plus? Should I do the addition in this way, or should I do it in this way? Is the upper one correct or the lower one correct? Yeah, Anushka.
Sir, the lower one is correct. Right?
Lower one or the upper one? Yeah, you need to both can be correct depending upon the situation. But what rule you need to recall that rule? Yeah, something related to rich gets richer. That's an easy way to remember it.
So was it like the group will be attached to the carbon atom which has got more hydrogen attached to it?
Yeah, hydrogen will attach itself to the carbon atom bearing more number of hydrogen. H will come here and Br will go there. So Ryan, Anushka and Imad, what this rule, what is a name this, uh, under which name this rule comes?
Sir, Marconi.
Yeah, it is Markovnikov addition, right?
Yes, sir.
Yeah. So Imad, can you recall Markovnikov addition?
So
It's
Markovnikov rule and Markovnikov addition.
yeah, Markovnikov rule, which or addition, which is governed by Markovnikov rule, which says, yeah,
Yeah. So if it's a protic acid, then it is added as an asymmetric alkene, right?
pardon,
Uh,
if it
Diacetyl
is,
hydrogen, diacetyl
yeah,
hydrogen attaches itself to the carbon having a greater number of hydrogen subsequently.
yeah, exactly. Yeah, H plus will get attached to the carbon atom bearing more hydrogens. H plus will go there where there are already more hydrogen. So rich gets richer.
Okay.
And the Br will go to the full carbon atom where there are less number of hydrogen. Okay, so the A is, so this is governed by Markovnikov rule, and this addition which is governed by Markovnikov rule is known as Markovnikov addition. And it is CH3, CH2, CH, CH2, H I am going to put here. I have shown it separately, but no need to show it, just to bring your attention. This is the final product. This is 2-bromobutane. That is the structure of A. Okay, 2-bromobutane, right? Now the thing is, you are doing alcoholic KOH, means KOH in C2H5OH and heat. So now again you are removing HBr because this is elimination reaction. Elimination of HBr. So let me write the A here. So what was, how can you do the anti-Markovnikov addition? Can you tell me in the meantime quickly of HBr? What reagent you used for doing the anti-Markovnikov addition? Anushka, Rehan, Imad, tell me quickly. Yeah, actually We did peroxide effect, Kharash effect, where actually the addition of HBr took in a reverse manner. H will come inside and Br will come out. If you would have taken this HBr in the presence of peroxide, so peroxide reverse the mode of addition, and this is known as peroxide effect or anti-Markovnikov of addition that is observed in the presence of peroxide. So I hope it is clear. Anushka,
Yes,
Imad,
sir.
Rehan?
Yes,
Okay.
sir.
Yeah. So addition is governed by Markovnikov rule or anti-Markovnikov rule. Okay. Similarly, elimination is governed by Setzeff rule and Hoffman rule. Okay. So elimination, that is for sure that you will get an alkene, right? So you are going to get an alkene, but there are two ways by which you can get an alkene. So one is this one. If you do this, okay, you are going to get one butene or but1-ene. Is it clear?
Yes, sir.
Yes.
This is the alkene which is formed on the outer side. And this is less. This is the alkene having less number of alkyl groups. There is only one alkyl group. And this alkene is Hoffman alkene. It is less branched, less stable. Okay. And it is formed in lesser quantity. It is the minor product. Minor product means not the juvenile. Okay. Means actually the product which is formed in less amount. Why it is? Because it is less stable. And suppose if you try to choose this elimination, okay, so then you will get a double bond in the middle because you removed hydrogen from the middle side. You can just enclose this alkene in a box and now count the number of alkyl groups on the carbon atom of the double bond. Okay, so there are two alkyl groups, this one and this one. So there only one alkyl group was there on one side. This is having alkyl group on two sides. So two alkyl groups. More substituted. Or more branched means more alkyl group, more branched. They are relatively more stable. And so these are the major products. Major product means this is the main alkene which is formed in the elimination reaction. And this is known as Z7. Or it is a Russian name, so it is also pronounced as Setzev. Rule. Or alkene. It is one and the same. Alkene, which is formed by following Setzev rule, is the major product. And Setzev rules tell us that during the dehydrohalogenation, during halogenation, if there are more than one possible type of alkene, which alkene is going to be the main product? So for that, you need to choose the alkene. You take the halogen and you remove the hydrogen from both sides one by one. You make those alkene. Okay, you enclose that alkene in a box and tell how many alkyl groups are there on that alkene, doubly bonded carbon atoms. So the major alkene is going to be the one which has more number of alkyl group connected to doubly bonded carbon atom, or more branched alkene will be the major product. And this product is, this rule is known as Setzev rule or Zetsev rule. Just the spelling is different. Both name are used, and it tells us that more branched alkene or the more substituted alkene is going to be the more major product in elimination, in dehydrohalogenation. Is it clear?
Yes, sir. Clear.
Okay, so wherever you have two different alkenes, you can just choose which one, but not everywhere you are going to get two different alkenes. Wherever the halogen is in the middle, there you are going to get the two different alkene. Okay, let me ask you one more question. Which reagent you choose for elimination? Yeah, Anushka.
Sir, in the previous question, the E, there was an E as well, right? We didn't do that, I think.
Yeah, this B and C. Okay, B is the alkene which is formed in more quantity. Yeah, right. So this is B, which is Setzev product, or product which is formed by Setzev group. And C is the minor product, minor alkene which is formed in less amount because it was less stable, and this was the alkene C. Clear?
Yes, sir.
Right? So I hope this is clear to all of you. Alcoholic KOH heat. So from where you are going to remove HNCl. So this is the carbon which is having Cl. You can remove either H from any of the two. CH3. Okay, but both are same, so you can choose any one of them. They are not different, so you should not consider them as two separate cases. You can choose any one of them, or you can choose the hydrogen which is on the left hand side on the CS2. This is different, and clearly you can see the difference. In this side you have ethyl group, that side you have methyl group, two same methyl group, so you can choose any one of them. So which alkene you are going to get? Okay, So the one which is formed by removal of on the left hand side, that is this one, and one alkene and the other alkene which is formed by removal of hydrogen, which is right on the right hand side to the carbon bearing the Cl atom. That is going to be CH3, CH2, C double bond CH2. This. So 2-methyl-butene is the upper alkene and 2-methyl-butanene is the lower one. A and B. Okay, these are the two possible alkene, which is going to be the major product. Yeah, Rehan, Imad.
Sir, B will be more the major one, right?
B will be, you need to enclose the double bond, and now you need to count the alkyl groups connected to the doubly directly connected to the doubly bonded carbon. So this is one alkyl group. Okay, this is another alkyl group. Okay, you need to look how many branches are there, and based on that you need to take your decision. Is it clear, Imad, Rayan?
Yes, sir. Clear.
Yeah, so you need to, so this is monosub, so B alkene which I have made, is it mono-substituted, di-substituted, tri-substituted, or tetra-substituted? Which one is it?
Sir,
Mono, di, tri, tetra. That is di-substituted because there are two alkyl groups. So di-substituted alkene. Okay. And what about A?
One.
Sir, A will be tri, right?
A will be tri. Yeah, right. You need to enclose the double bond and you need to count how many carbons are connected to this doubly bonded. So 1, 2, and 3. So it is tri-substituted. Okay. So what Setzeff rule tell us? What Setzeff rule tells us? It tells us that more branched alkene or the more substituted alkene is the major product formed in elimination reaction. Is it clear?
Yes, sir.
Right? That is a major product formed in elimination reaction. So this A is going to be the main answer. So suppose if nothing is given, you write the main answer only. Imad, Rayan, is it clear?
Yes, yes, sir.
Right? That is very, very important. You can just right. So A is a major product, B is a minor product. It is formed in less amount. Clear? So just you can try. Okay. So now let's do one question. How many different alkenes we will get if we treat N-butyl chloride with alcoholic KOH? Yeah, what is the name? IUPAC name of the alkene.
butene, sir?
Yeah, but1ene. So
Okay.
here are we going to get normal means just you have a no branching and all, just one after all the carbon are one after another. Rayan, Anushka, okay. So this one. So how many different alkene you can get here? So here you will get only one alkene. It is not that because we are studying that everywhere you will have two alkenes or three alkenes or no. There are cases where there is only one option. And which is that option? Let me show you why one alkene. This is the Cl, and there is only one hydrogen on that because one side only it is having carbon. Okay, is it clear? No carbon on other side. So you have no two options available, just single option. You can remove HCl. Okay, alcoholic KOH heat. Okay, just you will get one butene of but1ene. Is it clear? Right?
Yes, sir.
Okay. So it is not necessary that you will get always many different products, just one, sometimes one. So there is a question in your NCRT, how will you convert 2 bromopropane to 1 bromopropane? Yeah. So let me write the structure. Propane, 3 carbon atom, is 2 bromopropane, and you need to convert it into 1 bromopropane. So first of all, you need to remove this Br. Why do I need to remove this Br? Because otherwise, without removing it, I can't connect it on the other carbon atom. So I need to remove it. But the thing is, I can't remove only Br. I need to remove 2 groups. Okay, because I need to do elimination. So what I will use here, tell me, Anushka, Imad, Rayan, quickly tell me. Alcoholic KOH and heat, which is responsible for the removal of hydrogen and halogen minus HBr. Is it clear?
Okay.
So you will end up with an alkene. There is only one alkene because both sides, though there are 2 side carbon atom, but both are methyls of same. No difference if you remove hydrogen from right or left. If you have unsymmetrical structure, then you can get many different products, but here only one. This is propene. And now you need to bring in that HBr back. Okay. So how can you bring in that HBr again? You need to react it with HBr. But if you simply react it with HBr, the H plus is going to come to the outer carbon and the Br is going to come on the inner carbon, and you will get the first product from which you started. You are not going to get this product which is asked in the question. Is it clear? So what you will use? Tell me. What you are going to use here? HBr you are going to add. Definitely you need to add HBr. Yeah, Anushka. Rayan.
Sir, will we use aqueous Q?
You use HBr, okay, and but along with peroxide, okay, benzoyl peroxide, any peroxide are OO bond. Actually, they have OO single bond, and peroxide and light. Actually, they change the mechanism. Peroxide takes away the H with itself, so Br get added first. So Br actually added outside, okay, or benzoyl peroxide. So benzoyl peroxide is benzene ring COOO. This is the peroxide linkage. Okay, and this is used to start the reaction. Okay, and heat or light. Peroxide breaks very easily. It takes away the H. So Br get added first. Otherwise, simply if you take HBr, that is going to add as H plus and Br minus, and H plus will go to the position where there are more hydrogens. Okay, so this is known as anti-Markovnikov addition. And that will not happen normally. You require a peroxide, okay, anti-Markovnikov addition of HBr in the presence of peroxide. Okay, so you can try the back exercise of your NCRT, and we will discuss it next time. We are going to discuss just few compounds which are there, like chloroform, their properties of chlorofluorocarbons. Okay, just few. Okay, that is theoretical, and we are going to start with a new chapter, alcohol and ether, right?
Yes, sir.
Okay, so just you can try the questions which are given at the back in the back exercise. Lot of questions. Just this portion is remaining. Let me go. And you can try this question. So I took many examples today in today's class also related to the back exercise. Let me know this you can do, okay, completely. The substitution reaction, rate of SN2, okay, conversions, okay, right? Some of the conversions we will do it. So this we did, okay, and many questions we did today, and you can just try it on your own, just one by one, or 5 questions daily. So that will you will. Otherwise, what happens is that it is a very volatile topic. We forget it very frequently. Okay, so just you can keep doing some questions so that you can do all the questions after that. Okay, you will not forget. It will get into your long-term memory. So Grignard reagent and all. What we discussed a lot of things today. So let's move on. Let's discuss more in the next class. Mostly the last portion of this chapter, and hopefully we may move on to alcohol ether in the next class. Okay.